Hey Danya, so here is the inverse trig function. So we dealt with basically sine and cosine and sine inverse and cosine inverse on the previous lesson. So now we're going to look at the rest of them. Tangent inverse, cotangent inverse, cosecant inverse, and secant inverse. Okay, so that's what this one is going to be focusing on. Okay, and let's look at the restrictions. Okay, so we know some things now. Cosecant, because it's related to sine, it shares the restriction of its reciprocal sine inverse. So it's going to have sine values that are only on the right side of the unit circle in quadrants 1 and 4. Secant is related to cosine. It's the reciprocal function of cosine. So secant is going to share the restriction of its reciprocal cosine inverse, which is restricted to the top half of the unit circle graph. So the first and the second quadrant. Okay. To see the restriction for tangent, we look at its graph. Tangent passes the horizontal line test in between its asymptotes. So tangent's asymptotes are from negative pi to positive pi. So that means that it is restricted to, I'm sorry, where am I at? That was cotangent. Tangent, from negative pi over 2 to pi over 2, sorry. Because we set the b times x minus c equal to plus or minus pi over 2's. So it has a cycle between negative pi over 2 and pi over 2. This is one cycle. And if we restrict it to just that one cycle instead of including them all, we can make it 1-to-1. It'll pass both vertical and horizontal line test. So that means from negative pi over 2 to positive pi over 2, that's where it is restricted, which is the right side of the graph. Just like sine and cosecant. Okay. So that means tangent, sine, and cosecant are all going to be on that right-hand side. Okay. And then, or the inverses anyway. For the cotangent, remember, in between those two asymptotes, we have two cycles going on because we had that hidden asymptote in the middle, okay? It passes the horizontal line test if we were to chop off half that cycle. So if we go from 0 to pi or from 0 to negative pi or negative pi to 0 if we go from left to right, okay? So that means if we're going from 0 to pi, we are looking at the top half of the graph. So cotangent is also restricted to the top half, just like secant and cosine are. Okay. All right, so those are some other things that we have to remember, and they help us to narrow things down when we're looking for one angle, not just a possibility of angles, but one answer. Okay. So we're first going to look at questions that are on the unit circle. And again, I need to reiterate that we need to be in radians, okay? So the first one I have is the tangent inverse of -1. So our question is, where on our circle, where on the circle is the tangent -1, okay? Well, first of all, we need to draw a little picture of our unit circle, just a little baby one. Because remember, tangent, this was tangent, is only on the right side of the graph. So it's only in these two quadrants, the first and the fourth. Okay, so where would tangent be negative? Well, remember, tangent is the same as sine over cosine. So basically, where would the y value divided by the x value equal -1? Well, if we're in the first quadrant, both x and y are positive no matter what angle you are there. So there's no way you would get a tangent of -1, which means that it must be in that fourth quadrant. And the only way to get a -1 is if you divide a quantity by itself. And the only x and y value that have the same value are where in this quadrant x would be square root of 2 over 2, and the y value would be negative square root of 2 over 2. That's the, that would be negative pi over 4. Squeezing that in there. Okay, so that means that that's the answer. That would be negative pi over 4. Okay. Number 2, says the cotangent inverse of the square root of 3. Okay, and these, remember, these are on the circle. So I know that this is on the circle, even though I might not think that it is. So how do we get a cotangent that's square root of 3? Remember, there are some x and y values that are square root of 3 over 2. So we just need the over 2 part to cancel. And cotangent is the reciprocal of tangent. It's cosine over sine. So where on the unit circle could cotangent inverse be located? Well, up above, we just said cotangent is in the top half of the graph. So it's not going to be in the third or fourth quadrant. And the cotangent would be positive. So remember, cotangent is the same as cosine over sine, and it equals a positive square root of 3. So if I had x over y in the second quadrant, that wouldn't work because my x value would be negative, which means this would be negative. So it's not in that second quadrant. It's got to be in the first, okay? And I need the x value divided by the y value, okay? So that means that it's probably going to be this one, because this is where the x is square root of 3 over 2 and the y is 1/2. That's at pi over 6, okay? So I'm going to guess that, and to check it, let's divide cosine by sine. So that would be the square root of 3 over 2 divided by 1/2. But dividing fractions is easy as pi. Flip the second and multiply. And I'll look at that. The 2's cancel and we get the square root of 3. So the answer is a big whopping pi over 6. My throat's starting to hurt because I haven't done this much talking in a while. Okay. Number 3, the arc secant of 2 square root of 3 over 3. Where on the circle is the cosine square root of 3 over 2? So what we have to do is, well, we don't have anything that looks like this, so it helps when we flip it, okay? This is the arc secant. So I need to find the cosine. So the reciprocal of secant is cosine, because I don't know where secant is on the circle, but I know where cosine is on the circle. So when we flip this, 3 over 2 square root of 3, we can't ever leave a radical in the denominator. So we rationalize it. We get 3 square root of 3 over 2 times that 3 gets to come out. These 3 cancels, and all you have left is square root of 3 over 2. So where on the circle is the cosine, the square root of 3 over 2? Okay, so cosine, well, where is that going to be? Cosine is in the top half of the graph, so it won't be in the bottom half. And this cosine is positive, which means that we're not going to be in that second quadrant, so I'm in the first quadrant there. And let's see, when the cosine is square root of 3 over 2, the sine is 1/2, and that is the pi over 6 angle again. So this answer is also pi over 6. Okay, so those are all the questions that are on the circle. For the ones that are off the circle, that's what's next, and I'm going to keep up with my color coding here. So number 4, it says to evaluate to 4 decimals, cotangent inverse of 0.56. Here's the problem. We don't have a cotangent button on any calculator that anyone could possibly have. You will not have a cotangent button. So what we have to do is we have to rewrite it as tangent inverse, and then we have to put a 1 over that number, so 1 over 0.56. And when we type that in, we should get 1.0603. And so let's check. I should still be in radians because I haven't changed it since the last lesson. So tangent inverse of 1 divided by 0.56. 1.0603. So that checks out. All right, let's take a look at number 5, the arc secant of negative 2.35. Again, we don't have a secant button on our calculator, but we do have a cosine button on our calculator. So we could take the arc cosine as long as we put a 1 over the negative 2.35 to inverse it for the secant part. And let's figure out what that is. So second cosine of 1 divided by negative 2.35. And I get 2.0103. Okay. Number 6, to the nearest degree, we're finding the arctangent of negative 8.456. Well, we have a tangent button on our calculator, so I don't need to do any other changes. I just have to type this in. So remember, arctangent is tangent inverse. So I'm going to hit second and then tangent of negative 8.456. And I get, oh wait, did I misread something? Yeah, that wasn't it. To the nearest degree. Oh, whoops. That means I got to change my mode. So we have to watch out for that. It's easy to make that mistake. How do I exit? Okay. So I think it's in degrees now. So let's try it again. Second tangent, negative 8.456. So we should get a degree. Negative 83.3 degrees. Okay, so let's point that out for sure. Means we have to switch the mode. Mode switcher. All right, number 7, cosecant of tangent inverse of the square root of 2. Okay, so for cosecant, remember, or for of this problem in general, we need to work on the inside out. So we first need to work on tangent inverse. So let's look at the unit circle. And tangent is only on the right side of the graph. And we're looking for where the tangent is the square root of 2. Okay. So tangent is square root of 2. I have to use a reference triangle because this is not a unit circle problem. These are off the circle. Oh, duh. I was checking to see if it was on the circle, but I already know it's off because it says it up above. Okay, so it's off the circle, okay? And I know that tangent is square root of 2, and so that's why I put the opposite side as square root of 2, but the adjacent side must be a 1 because tangent is opposite over adjacent. So since this is not a fraction, any number can be made a fraction by putting it over 1, okay? Well, now I need to find that hypotenuse. So I'm going to use the Pythagorean theorem. 1 squared plus square root of 2 squared equals, we'll call it c squared because that's the hypotenuse. This is 1 plus, we're squaring a radical, so the number inside gets to come out. So that's a 3. And then square root both sides, c equals the square root of 3. So the hypotenuse there is the square root of 3. Okay? So now what we're finding is the cosecant of this. So we're finding the cosecant of the square root of 3. Remember, it's off the circle, okay? And cosecant is the reciprocal of sine. So let's find the sine. The sine of this angle would be opposite over hypotenuse, and that would be squared, so I should put theta. That would be square root of 2 over square root of 3. Okay, so to find cosecant, that would be the reverse of that. So that would be square root of 3 over the square root of 2. And we need to rationalize, so multiply top and bottom by radical 2. And these are both inside numbers, so 3 times 2 is 6, so square root of 6. Radical times itself means the number gets to come out. So the cosecant of the square root of 3 is square root of 6 over 2. Working through that problem. So these problems are very similar to the ones from the last lesson, except that we're dealing with all the rest, you know, secant, cosecant, tangent, cotangent. Okay, and on the next page is, oops, I gotta zoom out, is the homework. Okay, so go ahead and pause this and, or you know what, I'll make it a second video because I have to join a Zoom right now and I can't just stop it in the middle because it'll make me upload. So I'll post this in a second video. All right, have a good one.